Okay, this next page here is going to be dealing a lot with either linear pairs, vertical angles, or both right here. So a couple different angle pairs that we learned in this unit here. So this first one here is a linear pair, and I know that because next to each other when they're adjacent they make a straight line. All right, linear pairs will always add up to 180 degrees when you see the straight line. So the way you set this equation up is 3x plus 48 and then equals 180. Okay, and then from there you can go and solve algebraically. We can go and subtract 48 from both sides. That'll get us 132 there. Let me double check that. I think that's good. 80 minus 48. Yep, 132, and then we'll divide by 3, and that comes out to 44. All right, and that's just a value of x. That's not actually an angle, so just 44. You don't need any units or anything there on that. Okay, number 30, kind of the same thing. Got two angles that form another linear pair, so got to add up to 180. So that's x plus 2x equals 180. You can combine up your like terms. That's 3 x's. And then that's x after you divide. X is 60. Okay, and that'll be it there on that. Okay. Next couple of examples here. You got 31 and 32. 31, once again, that makes another linear pair right there. So these add up to 180. So you can go 6x minus 2 plus 7x, and then equals 180 degrees. We can combine up your x's there. I think you got 13 of them. We can add the 2. That's 182. And then hopefully 182 here is divisible by 13, if I'm adding this here correctly. Yes, it does. And that comes out to x is 14. That'll be it there. Now 32 is the first example where we're not dealing with linear pairs. These are actually opposite of one another when the two lines are intersecting. These are vertical angles here. And we know that vertical angles, instead of adding the 180, we say vertical angles actually equal one another. So that's just 8x equals 80. And then of course you would divide there by 8, and then that would get you 10 right there on that one. So that'll be it there on those. Okay, next two examples, you got some more vertical angles going on, but you got multiple variables on these here. So just kind of watch out here. On 33, since the vertical angles here are across from each other are equal, you can actually set those equal and say, whoops, yeah, I guess I'll just write this 5y plus 28, and then equals 7y. Now we'll go do the same thing here in a moment with the x's. It'll just be a different answer. Basically, this is two problems in one. I'm going to subtract the 5y from both sides and get, 28. Let's see, that's 2y. And then we can divide and we get y is 14. Okay, and that's it there for your y variable. You can go and do the same exact thing here for x. Go set your vertical angles, or the ones across from each other, equal to each other. And that's 3x plus 7, and then equals 4x minus 18. I'm going to subtract 3x from both sides. And that would cancel out, and that would give me 1x. And I still got the 18 over there, so I'll add 18. And that'll give me 25, I believe. And that'll be your variable for x. Now the issue is sometimes we get fixated on these vertical angles, and when we maybe look at a problem like this here, and we'll run into this issue here. You can't do anything with those vertical angles, because if you do that, if you set those equal, that's y plus 20 equals x plus 15, and you got multiple variables. So we don't want to forget that 2 on the same side can make a linear pair. So this one's kind of a trick one here. This one is a linear pair between these two angles right here, and that'll help us find x. And once we find x, we can go find y rather easily. So this one will be 3x plus 5 plus x plus 15, and then equals 180 degrees. Then you can go combine up your x's, 4x, and I believe 20, equals 180. We can subtract, and that's 160, and then we can divide, and that'll get us x is 40. So that'll be it there on that. Now, once we have x is 40, we can actually go plug back in and then use the fact that you have vertical angles. So if I plug in 40, that's 40 plus 15. That's going to come out to, what is that, 55 degrees. And then now that I know that this is 55 degrees, I can set my 55 degrees equal to the y plus 20. And then we can, subtract 20 from both sides, and that would get us 35. That would be your y value right there. So that one's kind of a weird one there. It looks like you would use vertical angles. You do, I guess, at the end, but you use the linear pair on this side here first on that. Okay, one more here on this page here. Let's look at this diagram here. Apparently we have angle ASD. Let me highlight that there for you. ASD, this whole thing is 120. And kind of like how I've been doing some of those vertical angles and stuff like that, maybe draw like a little dotted line right there. That entire angle, probably the best way to label it like that, right there with 120 degrees. They also do tell us that ASB, which would be this angle right here, if you're tracking the letters, that angle right there is the same thing or congruent to CSD. So those two are congruent. I'm going to put two little hoops there because they also tell us ASB is 2x. Okay. Now, if ASB is 2x and ASB is congruent to CSD, we can put another 2x down there. Okay, and then finally, they also give us that BSC right here is 3x minus 13. So we'll go ahead and squeeze in a 3x minus 13 right there. Now, once you get all that, then you can say all three of these need to add up to 120. So you can say 2x and then plus 3x minus 13 and then plus 2x and then equals 120 degrees. All right, and then you can go and, combine your like terms up. That's, what is that? That's 7x, I believe. 7x minus 13 equals 120. I guess we can add the 13. That'll be 143, or what is that? 133. And then hopefully 7 can go into that there. I think it does. Yeah, there we go. That gives us x is 19 right there. And that'll be it for that section.